this video, we're going to learn about formula mass and percent composition. So much earlier in this course, you learned about atomic mass, which can be expressed in grams per mole, and that was just defined as whatever the mass is of 1 mole of an atom. 1 mole being Avogadro's number, 6.02 times 10 to the 23rd atoms. Now, you're going to learn today about formula mass, which also can be expressed in grams per mole, but this is just the mass of a mole of a compound. It is the sum of all the atomic masses that make up a compound, and that's all there is to it. So if we're trying to find the formula mass of sodium chloride, all we'd have to do is look at the periodic table, find the atomic mass of sodium, and for that, it's going to be 22.99 grams per mole. For chlorine, that is 35.45 grams per mole, and we add them up, and we get 58.44 grams per mole. Now, you may be wondering why I cut off the decimals as I did. You can see, actually, if you look at the periodic table, that some atomic masses are extremely precise. Like sodium has, I don't know, 8 sig figs, maybe 10, I don't know. It's got a lot of sig figs. Lithium only has 3. You will be able to go 2 past the decimal place for everything. And regardless of the number of significant figures that is, you should just go to 2 digits past the decimal point. Makes it nice and easy, and as far as I'm concerned, that is precise enough to solve any problem that you'll have to do. Whenever you're doing calculations involving molar mass, you're never going to have the molar mass be the limiting factor on your sig figs, at least in any problem that I'll give you in this class. So for calcium nitrate, we now look up calcium, which is going to be 40.08 grams per mole. For nitrogen, that is 2 times 14.01 grams per mole. I'm doing this as a little bit of a shorthand, by the way. For oxygen, we have 3 times 2 is 6 times 16.00 grams per mole. And if we add those up, again, I know this is a little bit weird perhaps, but 6 times 16, we're going to get 96.00. 2 times 14.01 is 28.02. So really it's those two that we're adding to the 40.08. We should get 164.10 grams per mole. Now, next, we have formula mass, but for hydrates. Hydrates are compounds that have molecules of water trapped in their crystal lattice, and the molecules of water will exist in a specific ratio with the compound, the rest of the compound, I should say. So, for example, when we read this formula, we should read it understanding that in a mole of this compound, you have 1 mole of magnesium, 1 mole of sulfur, 4 moles of oxygen, and then there are 7 moles of water with that. There's going to be 1 magnesium sulfate formula unit with 7 moles of water crystallized with it. So if you're trying to figure out the formula mass, that dot there is not multiplication in the sense that you don't multiply 1 of like the magnesium sulfate times the 7 waters. That is just not the case. So here's how you would figure out the formula mass of this particular hydrate. You would look up the atomic masses. For magnesium, it's 24.31 grams per mole. For sulfur, it's 32.07, I believe. And for oxygen, that's going to be 4 times 16.00 grams per mole. And then we've got the water. I look at the water, I see 7 times 2 is 14. Sorry, 7. I'm losing my mind here. um, there's going to be 7 waters. And actually, to make this easier for something we'll do later, I'm going to figure out the formula mass for water on its own and then add that in. So I'm going to separately go like this. So we have hydrogen is 1.01, and we'll say 2 times that for each 2. Whoops. And the O is going to be 16.00. So that brings us to 18.02. Now, there are going to be 7 of these. So 7 times 18.02. This is going to be our mass of the water that's trapped in this crystal. And I'll also put this in here. So the water is going to come out to 126.14 grams. And then the magnesium sulfate is going to come out to 120.38. 120.38. And so actually the mass of the whole thing is going to be just the sum of these two. And when I add these together, the sum is going to be 246.52 grams per mole. So I've taken the mass of magnesium, the mass of sulfur, 4 times the mass of oxygen, that's here, and I've added in the mass of 7 waters, which is with 14 hydrogens, I suppose, and with 7 oxygens, which gets us to here. And our final answer, our final formula mass, which I'm going to mark a little bit differently than the other part that I circled, that's a 246.52 grams per mole. Finally, we need to discuss percent composition. When you think percent, think per divided by cent 100. It is the percent by mass of each element in a compound. Think part over whole, whatever the mass is of calcium versus the mass of the whole calcium nitrate, whatever the mass is of nitrogen versus the mass of the whole calcium nitrate. So what I can do is I can look back to how I solved this before, and I can just take that and copy it over. So we have, for calcium, it was 40.08 grams per mole. For nitrogen, it was 2 times 14.01, which equals 28.02 grams per mole. And for oxygen, that was 6 times 16.00 grams per mole, equals 96.00 grams per mole. And the sum of these is going to be 164.10 grams per mole, as we had before. This is for O, this is for N, and this is for Ca. But now, what is the percentage of calcium in calcium nitrate? Well, what is this? We have 40.08 over 164.10. This is grams of calcium per mole versus grams of calcium nitrate. That's going to be your percent. We'll have to, multiply by 100% to give us a percent. But that comes out to, what does it come out to? 24.42%. And with sig figs, I just leave it to the hundredths place again. Just 2 decimals past, or 2 digits past the decimal. For nitrogen, we have 28.02 over 164.10, and that's going to give us, when we multiply by 100%, that's going to give us 17.07%. Oops. And for the oxygen, that's going to be 96.00 over 164.10 times 100%. And that gives us 58.50%. And, minus a slight variation based on a rounding, you should be getting pretty much exactly 100% when you add up everything, which I believe is what we have here. So what this is saying is that calcium is 24-ish% of the mass of calcium nitrate. Nitrogen is about 17%, and oxygen is 58.5% of the mass of calcium nitrate. One last thing is that with hydrates, you may be asked to find the percent composition. You may be asked to, find the percent by mass of water in the hydrate. And so in order to do that, I'm just going to go back to my previous work here. We found that the overall molar mass is 246.52 grams per mole, but the water part of it is 126.14 grams per mole. So all I need to do is take the 126.14 grams per mole, grams of water, over the 246.52 grams of magnesium sulfate heptahydrate. I'll multiply this by 100%, and I end up with 51.12% water by mass. So that's it, formula, mass, and percent composition, including hydrates. Hope this video has been helpful. Let me know if you have any feedback, any questions, any comments in the comment section below. Thank you.